Some of the world's largest megacities are located just in the area of the most dangerous faults of the Earth's crust. Californians living on the San Andreas fault line are constantly threatened by devastating earthquakes. The scale of the destruction. When the dust storm subsided after the earthquake on April 18, 1906, a wave of fires swept across San Francisco. The disaster claimed 3,000 lives. This earthquake was the strongest in the United States this century, with a magnitude of 8.3 on the Richter scale, the tortured Earth. In desert areas such as the Carrizo Plain 160 kilometers north of Los Angeles, the San Andreas fault line is clearly visible. Here, the Earth's movements are highly unpredictable, and currents that have been following the same course for decades can suddenly reverse after another earthquake. Riverbed displacements of 120 meters to the side were recorded. Pressure band. Cracks in the road surfaces indicate a fault. In the area of the San Gabriel Mountains north of Los Angeles, the asphalt of the streets sometimes swells. These are the forces accumulating along the fault line, pressing on the mountain range. As a result, the rocks on the western side are shrinking and crumbling, annually forming up to 7 tons of fragments, which are getting closer and closer to Los Angeles. How can one not recall the remark that in this part of California civilization exists only with the tacit connivance of nature? At first glance, the streets of Taft in Central California are no different from the streets of any other city in North America. Houses and gardens along wide avenues, parking lots, streetlights every few steps. However, a closer look reveals that the line of the same lanterns is not quite level, and the street seems to twist, as if it were taken by the ends and pulled in different directions. The reason for these oddities is that Taft, like many California major urban centers, is built along the San Andreas Fault, a crack in the Earth's crust, 1,050 kilometers of which runs through the United States. The strip, stretching from the coast north of San Francisco to the Gulf of California and extending into the depths of the Earth for about 16 kilometers, is a line connecting 2 of the 12 tectonic plates on which the oceans and continents of the Earth are located. The average thickness of these plates is about 100 kilometers. They are in constant motion, drifting on the surface of the liquid inner mantle and colliding with each other with tremendous force when their location changes. If they pile on top of each other, huge mountain ranges such as the Alps and the Himalayas rise into the sky. However, the circumstances that gave rise to the San Andreas Fault are completely different. Here, the edges of the North American tectonic plate, on which most of this continent rests, and the Pacific tectonic plate, which supports most of the California coast, look like poorly fitted teeth of a gear that do not fit one on top of the other, but also do not fit neatly into the grooves designed for them. The plates rub against each other, and the friction energy generated along their boundaries does not find an outlet. The part of the fault in which such energy accumulates depends on where the next earthquake will occur and how strong it will be. In the so-called floating zones, where plate movement occurs relatively freely, the accumulated energy is released in thousands of small tremors that cause virtually no damage and are recorded only by the most sensitive seismographs. Other sections of the fault, they are called lock zones, seem to be completely motionless, where the plates are pressed against each other so tightly that there has been no movement for hundreds of years. The tension gradually increases, until finally both plates move, releasing all the accumulated energy in a powerful jerk. Then there are earthquakes with a magnitude of at least 7 on the Richter scale, similar to the devastating San Francisco earthquake of 1906. Between the two described above lie intermediate zones, whose activity, although not as destructive as in the castle, is nevertheless significant. The city of Parkfield, located between San Francisco and Los Angeles, is located in such an intermediate zone. Earthquakes with a magnitude of up to 6 on the Richter scale can be expected here every 20 to 30 years. The last one occurred in Parkfield in 1966. The phenomenon of cyclical earthquakes is unique for this region. There have been 12 major earthquakes in California since 200 AD. But it was the 1906 disaster that drew the world's attention to the San Andreas Fault. This earthquake, with its epicenter in San Francisco, caused destruction in a huge area stretching from north to south for 640 kilometers. Along the fault line, in a matter of minutes, the soil shifted by 6 meters, fences and trees were toppled, roads and communication systems were destroyed, water supply stopped, and fires raged throughout the city following the earthquake. As geological science has developed, more advanced measuring instruments have appeared that can constantly monitor the movements and pressure of water masses under the Earth's surface. In the years leading up to a major earthquake, seismic activity increases slightly, so it is possible that they can be predicted many hours or even days in advance. Please like this video and subscribe to this new channel, and you will see many more interesting and useful things. Architects and construction engineers take into account the possibility of earthquakes and design buildings and bridges that can withstand a certain force of vibrations of the Earth's surface. Thanks to these measures, the 1989 San Francisco earthquake destroyed most of the buildings of the old construction without harming modern skyscrapers. At that time, 63 people died, most of them due to the collapse of a huge section of the Bay Bridge. Scientists predict that California will face a serious catastrophe in the next 50 years. An earthquake with a magnitude of 7 on the Richter scale is expected to occur in Southern California, in the Los Angeles area. It can cause billions of dollars in damage and take 17,000 to 20,000 lives, and 11.5 million more people may die from smoke and fires. And since the friction energy generated along the fault line tends to accumulate, each year that brings us closer to an earthquake increases its probable strength.